So what is the earlier problem? To solve that problem, Java generics came into picture. Earlier, if you are adding element into list, you can add any item into that, like employee class also you can add, and list also you can add the student. Okay. So when you are accessing this data, always you need to check a instance of. If you not check and directly get that method from employee or student, either of that, because we don't know which type of object are there. So that time class cast exception came into multiple times. We need to cast like if, like list dot get, and we need to cast that into employee or student. If you haven't cast, then actually its cast won't happen, because any type of object we can save into this, and by mistakenly if you add any another instance, and we'll get another instance, that time here we'll get the class cast exception. So avoid this kind of problem, generics came into picture. So yeah, everyone I think use that generics, but I think they don't aware about the generics. So whenever you are defining a list, here you are writing a string, that these bracket, this is like means as a generics, means in your this ls object only string are allowed. If you say that ls dot add 1, here you will get a compile time exception, because this is not 1 is not allowed. You are saying strictly strings are allowed in this. Okay, that is mean by generics. So by definition, forcefully we are providing Java programmer to store specific value type of object, like here we declare. Why generics is required? Because of the type safety, like earlier we discussed employee and student object are in the list. So for a type safety it's required. Typecasting is not required, like this is known as a typecasting. So this is not required if you use the reflection. And compile time checking, like here we check about the ls.add. If you add 1 and define as a string, it's not allowed. Compile time exception, compile time error will getting. So yeah, these are the 3 advantages we are getting if you means it's using the Java generics. Okay. Like example map, also we know that example of map generics will take, like map is integer and it's supposedly stop string. Okay, so this is also way you can define the generics, like this is a key and this is a value. So you are saying that my key is should always integer, but value is the list of string, means only list of string are should be ingested is in a value portion of this map. Okay, so means multi-level these things also we can support. This is just a type safety, like only these kind of elements should inserted into my map. Okay, so yeah, that's the collection generics. But if you want to define own generics, how you can do, like this is already map is an implicit class, list is already defined interface. Apart from that, whatever we say, that set is already defined interface. But if this is an employee class and you need to define class employee, and this is a certain kind of object are only allowed here, so how can you do? So this is a custom generics. We'll talk about the how to do that and how to achieve that. Just before to providing just going ahead, whatever you are adding inside that, if you are writing a custom code, you should denote in a certain parameter, means that is already defined by Java. Suppose if you are defining at a class level, this is a type of thing, means like integer is a type, string is a data type, similar way. So if you are doing with the type, then t is the element, t is the notation for that. For element, e is the notation, key is the notation, n is the number, and v is for the value. Means if you want to define a map, then ideally it should be kv, and your class it should support it with the class employee in a kv format. So through the class, all that k and v passes through this map. Okay, that's the way. Okay, we'll talk about in details with the example. This is just a knowledge basis, what are the notation and what are the reserved character to identify the correct thing. Okay, so it a class, if you check the class example, like class is a my generation class, and if I pass t as a here, and if I say t dot t is object and t dot get return object, so that time if I pass here like my, like if I want to use like my gen is a object. Okay, so if I create a new my gen string, this is the way I created object, and when I call, like here I am passing that object, the constructor initialization is not there, but yeah, if I say that this new object is assigned to the employee, and when I say employee dot get, then I will 100% I know this is a string class, because why my gen creation I passes the string as an input here. Okay, this is the string type. So when I call any get method of this, I know I am damn sure that t means the string output will be there. Okay, this is a way where you can define the class, like t, how it's get mapped with the t. It's a similar like list of string. Okay, so whatever you are doing that operation, it's on a string basis. New array list we are doing. Okay, that's the same. Okay, this is a class level. If you want to method, how you can do that. This is an example. Next example, like public static e means the element, void element we are supporting here, void print array, e is the array of element. So if you want a print, you can just simply create a like string my array. In this you can say a b c d e f. Okay, you created this my as an array, so I can call this print array method just passing my. Okay, what should be output? So I passes print array my array as an element as an array. So here e is the string and the array. Okay, e means, and here we are printing the element, means all the strings of this abc and def on a console. On a console I will get to know ki abc and def get printed. Okay, because in a print array e is a element of array. Here string is the element and we are passing string array in this print array method. So that's why it work like that. Okay, this is a 2 example class E. Similarly you can check on a key value and a number. Everything is similar like that. Apart from that, generics have provide some additional things, like here we are only passing string or integer or a number, but additionally you can pass like as a the thing like upper bound means wildcard have the means star means anything and question mark means inheritance. Okay, so if you say star means any class which extended from number, that is allowed here. So from number, you know that from number integer is extended, then number float is extended, double is extended. So all the things are allowed at here. So question mark is means that are the data types are allowed here in this example. Okay, this is the example for upper bound, means up we are this is the hierarchy, and in this hierarchy we are bounding at this level. So all are allowed, these 3 are allowed because we are restricted at this place. So above that is not allowed, but below 3 child are allowed because we are upper bound. So this is the upper bound wildcard generics. Okay, then unbounded wildcard. Unbounded means this is the star, means whatever you want pass, you can just simply pass. No need to define a property in anything. Then lower bound means we are saying that super of integer, means all the numbers are allowed here because this is my number and this is my integer, and I am saying super class of integer is allowed, means integer super is a number, so number you can pass here and we can do that. So this is the lower bound, means we are saying that this is allowed, means during number to these are the allowed field in this thing. That's why it's the lower bound, and the reverse way is the example of a upper bound. And yeah, unbounded means nothing need to, it's just the question mark, whatever you want to pass. Yeah, but here if you check that if you pass as a here, if you suppose there float or any data type is there, then float is not allowed. But if you convert that float into number interface and you can pass, then it's allowed. Okay, so just need to typecast from here to here and you need to pass, and that goes into that function. Okay, yeah, that's it basic about the generics. So we check about the what is generics, why it's required, how it's implicitly work. If you want to custom, how can you customize that, and we check lower bound generics, upper bound generics, and wildcard entries. Yeah, that's it for today's session. Yeah, thanks all, bye.